average response time jumped from 45 ms to 245 ms after adding a Redis cache handler. The team fixed performance by making everything slower. Let's break down custom cache handlers, Redis, memcached, and distributed caching, how it works, and the exact mistake behind that failure. A custom cache handler in Next.js 16 is a pluggable backend for the framework's incremental cache, the layer that stores rendered pages, fetch responses, and data caches. By default, Next.js stores cached data on the local file system, which is fast and zero configuration but ephemeral and instance local. The default cache handler stores data as files on the local file system. Local file I/O takes 0.5-2 ms per operation, faster than any remote cache for single-instance deployments. The limitation is that it's not shared across instances, so for multi-instance setups, you may need an external cache. cacheLife profiles let you define reusable TTL settings for different data types. Each profile specifies how long data can be stale, when to trigger background revalidation, and when it expires completely. Register profiles in the root layout so they're available everywhere. Here we register 3 cacheLife profiles: products, blog, and session. Each defines stale, revalidate, and expire timestamps in seconds. Once registered, any fetch or data call in that root segment can reference the profile by name. cacheTag lets you tag cached responses with arbitrary strings and invalidate them on demand. You tag a fetch call with tags like products, then call revalidateTag, products, anywhere in your app to mark all cached responses with that tag as stale. Here we tag a fetch call with products. Then in an API route, we call revalidateTag, products, to invalidate all cached responses with that tag. The invalidation is lazy. It marks entries as stale, and the next request triggers a background refresh. The Custom Cache Handler API lets you replace the default file system cache with any key value store. The handler is a class that implements 5 methods: get, set, has, delete, and revalidateTag. Next.js calls these methods for every cache operation during rendering. This is a complete Redis cache handler using upstash Redis. It implements all 5 required methods. Note that revalidateTag uses Redis keys pattern matching. This is fine for development, but should be replaced with a tag-to-key index in production. The Stale-While-Revalidate pattern serves the cached stale response immediately to the user, then in the background refetches fresh data and updates the cache. The user never waits for the origin. The stale window must be large enough to absorb traffic spikes. This timeline shows how Stale-While-Revalidate works. At t=16 minutes, the stale window has passed, so the request triggers a background refresh but still receives stale data. The refresh completes in 100 ms, and subsequent requests get fresh data. Not all external caches are equal. Redis is best for single-region multi-instance deployments. Memcached is simpler and more memory efficient. Cloudflare KV provides globally distributed edge caching. For global apps, use a 3-tier strategy: KV at edge, Redis in region, origin as fallback. Here's a Cloudflare KV cache handler. Note that revalidateTag is not natively supported by KV. You need a different invalidation strategy, like version prefixes. This handler is best for read-heavy, globally distributed apps. When a server action mutates data, it should call revalidateTag or revalidatePath to mark affected cached data as stale. RevalidateTag is data scoped. It invalidates all pages using that data. RevalidatePath is root scoped. It invalidates a specific route. Pair with optimistic updates for instant UI feedback. This server action updates a product price, then calls both revalidateTag, products, to invalidate all product caches and revalidatePath for the specific product page. Both are lazy, they mark stale, not rebuild. Next.js handles the thundering herd problem through request deduplication. When a background refresh is triggered, Next.js coalesces concurrent requests. Of 10,000 simultaneous requests, only one triggers the actual revalidation. The other 9,999 receive the stale cached response. This conceptual model shows how deduplication works. If a refresh is already in flight for a key, New requests wait for it and then get stale data. Only one origin call is made per cache key, regardless of traffic volume. This is the same issue we highlighted at the start. Here's exactly why that happened. The team deployed a Redis cache handler on a single instance app. Every HTTP request triggered 3-4 cache operations, each requiring a network round trip averaging 8-15 ms. The total overhead was 24-60 ms minimum, and under load, Redis CPU hit 70%, pushing P99 latency to 45 ms per operation. The custom Redis cache handler added 200 ms per request due to network round trips, while the default file system cache was 100x faster for single-instance deployments. The fix was to remove the custom Redis handler and revert to the default file system cache. They also added Xcache timing headers to every response so future developers can see cache latency. For single-instance deployments, the default FS cache is optimal. Only add Redis when you have 2+ server instances sharing cache state. This is the exact line that caused the incident. The team added a Redis cache handler to a single-instance app where the default file system cache was faster. The network round trips added 200 ms per request, making the system slower than with no cache at all. Tags are case-sensitive. Products and products are different tags. Standardize on lowercase tags and enforce via linting to avoid this bug. Setting stale and revalidate to the same value means every request arrives with elapsed time exceeding both, triggering a background refresh on every request. This floods your origin with revalidation traffic. Keep the stale window 3-5x larger than revalidate. Using revalidatePath/products only invalidates the listing page, not individual product detail pages. Use revalidateTag products to invalidate all pages tagged with products, including detail pages and search results. The custom cache handler API, cache handler in Next, config TS is available in Next.js 16 and later. In Next.js 15 and earlier, this API does not exist. The only way to customize caching was via the onRequest hook or by using a custom server. Ensure your project uses Next.js 16+ before implementing the patterns shown in this article. The article warns against using keys in revalidateTag for production. Here is a concrete implementation using a Redis set to maintain a tag-to-key index, enabling O1 invalidation without blocking the event loop. When using a raw Redis client like Redis in a long-running Node.js server, not serverless, configure connection pooling with a limited pool size, e.g., 1020 connections, and enable retry strategies. Without pooling, each cache operation may open a new connection, adding latency and exhausting Redis server connections under load. For serverless, prefer HTTP-based clients like Upstash Redis to avoid cold start connection overhead. To diagnose cache performance, add Xcache timing headers to every response. Use curl to check them. For Redis, check keyspace hits and misses. To debug tag invalidation, grep your codebase to ensure tag strings match exactly. Let's run through some common interview questions. How would you design a custom cache handler for 4 instances? Implement Redis handler with get/set/has/delete/revalidateTag. Use dual write migration, measure hit rate and latency. Explain Stale-While-Revalidate in cacheLife. Serve stale data immediately, background refresh after revalidate window, stale window 3-5x revalidate. How to invalidate 10,000 product pages. Use cacheTag products on all product fetches, then call revalidateTag products after mutation. And a few frequently asked questions. When should I use Redis cache? Only when you have 2+ server instances sharing cache state. How do I migrate from FS to Redis safely? Use a 3-phase migration over 3 TTL cycles. Write to both, read from new, then remove old. What metrics should I monitor? Cache hit rate 80%, latency P99 50 ms, revalidation count, eviction rate. Let's recap the key takeaways. Default FS cache 0, 5-2 ms per operation. cacheLife, single source of truth for TTLs. cacheTag, on-demand invalidation. Stale-While-Revalidate, never block users. Ready to go deeper? Up next, MDX, content management, and draft mode in Next.js. The Next Config, TS Deep Dive, all configuration options explained, then Pages Router to App Router migration, step-by-step guide, and Next.js project structure, folder organization best practices. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.